Okay, we're gonna go through the lesson we did today. There's two parts. So I'll do the first part, which is about our sampling distribution for means. So we'll go ahead and take a look at the example we worked on in class. So what we did is we have a sampling distribution here, and this how tall are high school students, high school seniors in Virginia attached to the heights of all 50 high school seniors in a small high school in Northern Virginia. So what we're looking at is if we look at this distribution, let's make a guess at the mean of the 50 and standard deviation. So if we look at this appears roughly symmetric to me. I mean, like if you really look at this, this is definitely roughly symmetric. And what each one of these dots means, each one of these dots is the height of one student. So like, for example, this one right here is a height of one student. That's about 188 centimeters. So if we're going to make a guess of this, since it's roughly symmetric, we could use mean, but in this case, let's take in the case, the mean, what we would do is if we guessed at this, take a look. I mean, where would you think the mean would be? The mean would probably be somewhere near the middle. So if we're going to ballpark it, maybe we'd say the mean is maybe 170, 169. If we wanted to figure out exactly where the median is, we could go to the 25th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So if we wanted to ballpark it, our mean guess would be about 170 centimeters. And if you want to think about the variability there, it's like kind of how spread out it is. It goes all the way up to 188. It goes all the way down to 140. So, I mean, realistically, that's kind of more of an outlier-ish kind of person. So let's say we're going to take a guess of the standard deviation. It's about 18 up. And remember, we talk about 3 standard deviations up, 3 standard deviations down. So I'd probably guess about 6 centimeters is what my standard deviation is. What we did in class is we took this sheet right here. It's 50 heights. So you take, we took 4 samples. And we got the average height of those 4 people. So it could vary. So let's say, for example, we just so happen to get, persons 1, 2, 3, and 4. So we got 180, 158, 173, and 175. What we need to do is if we want to figure out the mean of that, that's called the X bar. Just go ahead to the calculator and we do 180 plus 158 plus 173 plus 175. We divide it by 4. We end up with like 171.5. And what we would do is we'd repeat that process multiple times. So what we do is we go get samples of size 4, and we're going to do that in class. What ends up happening is we end up with a sampling distribution, and let's just give a ballpark of what it would look like. I mean, this is an example that I'm using, but here's the sampling distribution I have. Notice here all these dots, they're kind of centered on where we think the real answer is. So they all kind of center on 170, 169, 170. Each one of those dots represents the mean of 4 students. So if we wanted to describe that shape, we'd say that that's probably roughly symmetric. It's got a single peak at 169. The center is about 169 centimeters. And the variability here looks a little bit smaller. It actually looks, if we think about it, we go from 169 to like 179 or 169 down to like about 162, 163. So if we look at that, we actually definitely have a little bit smaller variability in that case. Our variability is about 3. If we look at the 2 dot plots together, so again, we want to look at those 2 dot plots. This is the actual population. This is the sampling distribution. They're both centered at roughly the same place. But this one definitely has less variability. And what we're going to find out today is that there's actually a set of rules that we're going to abide by on that. And those rules are going to say the following. We're going to do some checks, very similar to the checks we did before. The first check we're going to do is for our center. And we're going to check to see if something's done randomly. If something is done randomly like it was before, we can go ahead and say that the mean of all of those X bars is going to be equal to the true mean, much like the mean of all the p hats equal the true proportion. The spread, what we are going to do with the spread is we're going to check the independence again. So again, we're going to go ahead and check independence. And that was my 10n check. So my 10n check was I needed to make sure that 10n was less than or equal to big N. In this case, we're dealing with 5 students. It should have been 5 students there. 5 students, so 10 times 5 is 50. 50 is less than or equal to 50. What we can then say is that the standard deviation of that is going to be equal to what the true population standard deviation is divided by n. And then the shape. Before, when we did, and this is a new one, before when we did this, we dealt with proportions. We were looking for 10 or more successes. We were looking for 10 or more failures. In this case, it's something different. 2 things to look for. The first thing we're going to look for is if the population is approximately normal. If the population is approximately normal, I can say that the sampling distribution is approximately normal. Well, I don't know if that is the case here. I mean, I can do some proofs to check it out, but I would need to know, it would have to say that heights were approximately normally distributed. And the other one that we're going to learn about in the next video is something called the central limit theorem. We refer to it as an abbreviation CLT. And what that tells us is that if our sample size is 30 or larger, it's some calculus stuff we do. It proves to us that it demonstrates that it's most likely that the sampling distribution is going to be approximately normal. So in this case, we didn't exceed that. So really, it would be hard for us to tell the shape being approximately normal. So hopefully that helps. That's a little bit of what we talked about first.